Map is an interface in Java that provides method for storing key value pair as a collection. Today we are going to discuss about HashMap class, which is an implementation of the map interface. So to start, we can start with map, and we can have key and a value type. So for the key, we can say an integer, and for value, we can say string. So we can define a map, and we can name it as data equal to new, and here we're going to use HashMap. And for the HashMap, though we have not provided any type, but given that for the map interface we provided type, by default it is going to pick up the type of integer for the key and string for value. And here, instead of map interface, if we just use var, in that case the HashMap will not have any specific type. It will have object for both key and value. So let me undo the change and let's get back to map. Now for adding data to a map, we can use the function called put. So we can say data.put, and put is going to add the key value pair into the map. So we can say 1 for the key, and for the value, let's just say 1. Similarly, we can have two other. So we can say for the key, we can say 2 and 3. For the value, 3 and 2. And now here, if we do system.out.print, and we want to print the value where key is equal to 2, for that what we can do is we can use the get method. So we can say data.get, and the get is going to take the key, and in our case it is going to be 2. Now if we compile and run this application, we should see it is printing out the word 2 in the output. And you can see, as expected, it is printing out 2 in the console here. Apart from just adding, if we just use the put method here, and if we try to add the same key again, for example, we want to add 2, and here we say new 2. What this is going to do is this is going to replace the existing value with the new value. So if we compile and run this time, we should see new 2 instead of 2 for the key. And you can see new 2. Now what happens with the put? Put actually returns a value. So you can see here the put returns the previous value associated to the key, or null if there was no mapping. Meaning here, if we do system.write.println, during the first time we add 2, this is going to return null. Whereas when the second time we try to add 2 using the put, this time it should return the previous value which was mapped to 2, which is the word 2. So let's try to run this. And you can see first time it printed null because there was no value associated to 2. Second time when we try to put, it printed the 2 word because that was the previous value. And third time when we were calling get method to get the value associated to the key 2 and print it out, it is getting the new value, which is the new 2 which we added recently. So this is how we can use put. Now apart from put, there is another method which can be used for replacing value, and that method is replace. The main difference between replace and put is that replace has 2 overload. The first overload takes the key, the old value and the new value, and if it is replaced properly, it is going to return a true. And the advantage of this overload of replace is that you can ensure that only the old value is being replaced by new value, and that gives an extra layer of security. That's about it. And the second overload of replace, it just takes this key and changes the value for the key that we specified. Now this one returns the previous value associated with the key, or null if there is no mapping for the key. Here the put and replaces behaves the same, but the difference is, unlike put where if a key doesn't exist it is going to add the key, in case of replace, if the key doesn't exist it is not going to add the key. So let's try this out. If we do a replace, now here it should replace fine without any issue, and we should see the same output as before, which is null 2 and new 2. And we can see null 2 and new 2 because it replaced 2 with new 2, so this println printed 2 and then finally new 2. Now here if we change this and we make this as 4, the key 4 doesn't exist. Now let's run. This time you see that first one is null because this is, you know what, let's get rid of this because this is unnecessary, creating confusion in the printout. So let's compile. Now we have only 2 printout. So this time you can see that 4 does not exist, so it just returned a null. Now if we try to print out the key 4 here, it should not work because, as I mentioned, replace do not add the key if it does not exist, unlike the put method. So this time you can see when we try to get with the key of 4, it is printing out null here, which is the expected behavior. Apart from the put, get and replace, the other thing what we can do is we can use the remove method to remove a key. For example, let's get rid of this, and here if we say data dot remove, and you can see this removes a mapping for a key from this map. So if we say 2, it is going to remove 2 and 2 here. The map method returns the previous value associated to the key, or null if there was no mapping found. So if we do a system.write.println here, this should return the word 2, and that should be printed out. And after that, when we try to get with the key 2, it should return null because the 2 would have been removed by then. So let's again compile and run this code, and we can see that first time it is returning 2, which is during remove because it had the value 2, and second time when we did a get and try to print it out, it returned null because this value has been removed. Now let's try to remove a key that doesn't exist. At this time the remove should return null because the key does not exist in the map, and you can see it is returning null because the key doesn't exist. So that's how we can remove. And then the other important method for the map is contains key. So if we want to, for example, before we remove something, if we want to see if the key exists in the hash map and then remove, we can use data.contains key, and here we can provide 4. So if it contains key, then we can say, if it contains key, then we'll just do this, which is remove. Else what we can do is we can do a system.out.println, and we can say key do not exist. Now if we run this time for the 4, because we are checking contains key and the key 4 do not exist, we should see the printout that key do not exist, and we see that key do not exist. So this can be really handy. This contains key method can be really handy to determine whether a key exists before we try to delete, and the same can be used during replace or update. Now for the replace, one method that I did not show is the replace with 2 parameters. So let's try that out also. So if we do data.replace, what I meant is the replace with 3 parameters. So If I want to replace 2 whose value is 2 with new 2, should we replace, not remove? Now this is going to work fine. We should be seeing 2, and if I do a system.out.println here, this is going to return a boolean, so we should be seeing true. For this printout it is true boolean value, and for this printout it should be the new 2 word. So let's try compile and run, and we can see it is true because it was able to replace, and then the new 2 is provided. Now here, if we just change the 2 to 21, now the key and value is not going to match to the key and value in the data because we don't have a 2-1 associated to the key 2. So in this case, the replace will return false, and for the key, it is going to return the existing key, which is just 2. So let's try this out. And we can see that it is returning false, and it is returning the existing value associated to the key 2. So that is all I wanted to cover for today's video, an introduction to map and the class HashMap. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to this channel. And thanks so much for watching this video.